Well, this is the most whimsical concoction we've seen in a while. Hi, David.
Hi, Bob.
How are you? What's the big idea here, hanging a sports car off of one of your beams?
Oh, we've just been showing off hanging the car from the beam and putting the beam on corrugated containers.
You mean you've got the weight of the car and the beam on these cardboard boxes?
That's right.
It's pretty impressive. You guys have some neat ideas around here. But what I want to know is how you make those beams.
Bob, we're all ready to show you at the plant.
Great. So what do we got here, Dave?
Well, we have the veneer from which we make our product. We can not only utilize this good veneer that you'd use in other processes, we can use what is considered waste. We call it fishtail. It comes because the log isn't perfectly round when we start the process.
Yeah, so this has been veneered off of around, is it Douglas fir?
That's right.
Yeah. Where's it grown?
In Oregon, Washington, and here in British Columbia.
So none of it is imported.
That's right.
And it looks like it just got veneered a week ago. What's the moisture content?
It's high. It's about 30 to 70% water in this pile right now.
So what's the first step in making
Our first step is right over here, and it's drying the veneer.
Okay. How do you actually dry it?
When we take the wet veneer and we put it right into these machines, it travels on these belts throughout a dryer blowing hot air at about 170 degrees Celsius on both sides.
How hot is that in Fahrenheit?
About 340 degrees.
And does it get all the moisture out of it?
Down to about 2 to 4%.
Fabulous.
When the veneer comes out of the dryer, we sense the moisture content, and if it's too wet, we mark it with a black paint and then put the veneer back through the dryer a second time.
And what's the next step?
The next step is the veneer goes right into the strander.
The strander. So you're actually shredding that big sheet into strips.
What we're really doing is cutting them into long strips. The machine is like an old-fashioned real lawnmower that cuts them in these strips. The long ones give us strength. The short ones don't. We want to get rid of those.
So why do you switch direction here on the conveyor belt?
That's because they've got an ingenious device that the long ones have to jump this gap.
You got a gap here. As long as you've got them on a diagonal, the long ones go through and the short ones fall in the...
That's right. Then they're ground up and they're used for energy to heat the dryers. We try and recycle the whole material.
Fabulous. So all of these will actually become a beam. What's the next step?
The resin is applied to the strand.
So what's actually happening within that mechanism?
This is our resin application system. It applies the resin and it dries the excess water off the strands, and then they come up the conveyors to keep the steam water.
What kind of a glue have you used for this resin?
This is a phenolic resin. It's the same as used in waterproof marine plywood. It's been around 50, 75 years.
Okay, these are basically the only two ingredients, right?
That's it. That's
the wood and the glue. What's the deal with this conveyor belt below us?
This is a belt that has a conveyor that moves around in a circle, but at the same time the whole belt's moving back and forth.
Yeah.
And what it's doing for us is dropping those strands down into the top you can see on the right, so they're parallel and so they're well overlapped. Both the parallelism and good overlap are critical to the strength of our product.
So it's a linear overlap, and that is strength and union. Yeah.
That's right.
And where are they going here?
And what we have down here is a trough that by the time this trough is always moving towards our press.
Yeah.
At the same time, the vat is about 30 inches deep, and it's in the press. It's slowly compressed down to about 11 and a half.
30 inches down to 11 and a half.
That's right. That's it.
Wow, that's amazing. Okay, Dave, so what's going on here at these controls?
The total process line is controlled by this computer.
Yeah.
Density, moisture content, speed, the length of the beams that we cut off.
Right.
The whole thing is done right here.
Okay. And then what's the next step?
The curing, the pressing and the curing. The whole beam is cured by microwave energy, gets it over the boiling point of water. That solidifies the product and gets a good glue bond.
So that's over 212 degrees Fahrenheit.
Absolutely.
Great. And then what?
We have the pulling stations, which exert over 100 tons of pulling force that help pull the beam right out of the press. Without them, the press would jam shut. It wouldn't work.
Of course, because of all that pressure that's being exerted there.
That's right.
Great. And what happens?
What we have next is a flying cutoff saw. This clamps onto the beam, to the length we want, and then it comes right across with a blade and cuts it off to the length we want. Right now, the market's asking for 48 feet length, and the whole deck is full of 48-foot long beams.
But you could make them kind of, it seems, as long as you would want, right?
It's a continuous press, and we could theoretically, if we could handle it.
Yeah.
In reality, 66 feet is about as long as we produce under normal circumstances.
Then what's the next step after you've cut them to length?
The beam is then put through the sizer, which just cleans up the outside edges, makes sure it's perfectly square. Then if we want a smaller cross-section, it goes through a saw that cuts it down to a smaller cross-section, through a sander that sands all the sides. Then it goes through an intensive grading process to make sure there are no flaws in it. We wrap it, and we're all ready to send it out to the market.
It's packaged and it's ready to go into a building site. That's great. Tell you, what's amazing is the scale of everything is so huge here. How big are these Parallams that they're loading there?
These beams are 48 feet long. It's here where we wrap them, package them, put them on the trucks or the rail cars in the back, and they head to any market in North America.
All over the country.
That's